Thank you. Hi, everyone. How's your day going so far? Good? Yeah. This is a kind of a tough spot for a talk because I'm like right before lunch, so I have to talk over all your grumbling tummies as we get into there. So you might be thinking CSP, Content Security Policy. Some of you are probably familiar with this before, and you're wondering, hey, why is this guy doing this talk on this thing that's been around for a while? And I got to doing some research earlier this year because I was curious how much of the, how are companies actually leveraging it today, you know, with modern applications, with the proliferation of just applications in general on the web, has it actually gained a proper level of being adopted? That led me down the path of, hey, you know, I found out some interesting things. I was just doing some research for myself, and then I decided, okay, I'm going to make this talk on it. So this is the result of that exercise. My mic's going in and out here. Hang on. Making a little adjustment because it sounds like I keep coming in and out. Okay, so who am I? I'm the CIO at Secure Ideas, which is we're a pen testing company. We have about 30 people, which in a company that size, if you're the CIO, that means you basically do all the jobs. So, right? So I do a little bit of everything, including penetration testing. I'm also an IONS faculty member. Has anyone heard of IONS here? Maybe a couple people, yeah. So IONS is an expert support system. They match up experts in certain fields with companies who are looking for those experts to help them with decisions. So my area of expertise for IONS is in application security, so it's kind of in line with this talk. I'm also an OWASP project committee member. So if you've heard of OWASP, hopefully if you're into application security at all, you have. So I help shepherd the projects through the various different processes and whatnot there, and determine, you know, if somebody brings us a new project, where does it actually belong? Is it something that's new, or does it belong to another project? Those types of decisions. I've been doing some form of pen testing since 2009, so it's been a while now. And I've been programming for even longer than that. So I was a software developer. My first computer was a Commodore VIC-20. Anybody know what that is? Yes. Okay, we got a bunch who do. Okay, that was my first one. I saved up. I was just a kid. I saved up my money from mowing lawns, and I bought a VIC-20. And then I did the first thing that a kid's going to do with a VIC-20 at that age, which is build a Dungeons & Dragons character sheet generator program on it, because, you know, I'm a bit of a nerd that way. Which is a challenge, by the way, because, you know, the Commodore VIC-20, that's only 20K of actual memory in there. And once you load the operating system, you're down to less than 4K for actually writing a program, right? So you're pretty limited. So one could say I actually started hacking things since much sooner. Anyway, on from there, I have some other interests. I don't think those are particularly pertinent to this conversation. So I'm just going to jump into content security policy stuff. So what this is, in a nutshell, if you haven't heard of this before, that's okay. I know the talk is advanced tactics, but I'm going to go over the basics too. So content security policy is something that's already built into your browser. Every browser has one. Every modern browser has one, okay? Has the ability to support the content security policy. What it does is it lets you turn features off in the browser. Things that it would normally do, it can turn them off or restrict their use, okay? One of the main ones that we think about with content security policy is the ability to run JavaScript. So with the CSP, content security policy, you can help define what JavaScript is allowed to run within, you know, a particular page, right? That's one of the main use cases we think about when we say CSP, but there's actually a bunch of other things that it can do that a lot of people don't really know about. Now, it is a tool in the toolbox. So it is, you have other controls in place. You can do your output encoding, your input validation. There's lots of other things that you can do. You can have WAF in front of it. There's lots of other things you can do to like prevent cross-site scripting attacks, let's say. So this is yet another tool. And the convenient thing about this tool is it's available across all browsers already. It's already there. It's not something you need to install. It's not something that costs extra money. It's there. Unfortunately, a lot of people don't really make good use of it. So on the screen right now, I have a couple of just little examples of content security policies and what they do. So the default source just means allow anything, but only from the same origin. So when we're talking about same origin, what we mean by that is, like, if I load a page from www.example.com, then anything else that's loaded from www.example.com is the same origin. As long as it's the same port, protocol, and the domain's the same, it's considered the same origin. Anything outside of that is a different origin, right? So whenever we have the word self in here, we're talking about it allows loading from the same origin only, and it restricts anything that's not self, right? Does that make sense? Okay. So what happens in your browser if you have a violation against a content security policy, and I have some examples of this later because I'm actually going to show you a live demo. But what you're going to have is you're going to have an error message that'll look something like this. Like I know it looks all scrambled together on the screen, but this is basically saying executing inline script violates the following content security policy directive because on this page I had a CSP defined, and then I tried to run a script and it failed because it didn't meet that policy. So what it's going to look like is it's going to tell you, hey, this failed because of the CSP, and here's what you need to do to fix it. And it actually gave me a hash on there of the script that failed, so I could put a hash instruction in my CSP, right? It also talks about using a nonce, and I'm going to go over these in a little bit more detail. And then it also says, you could also use unsafe inline, which, by the way, the word unsafe is a hint that you probably should avoid using that one if you can, right? So jumping ahead to the stats. So what I did is I built a program. AI's been great for this sort of thing. I want to do some research on the internet, call AI for some help on building scripts to do things quickly, right? So I built some scripts to basically scrape the content security policies off of the top 1 million websites, according to the Trinko list. There's actually only about 760 some odd thousand that resolved with where I actually got a website to resolve on it. So it's not a full sample, but that's still pretty big. It's still 750,000 sites I have up there that I pulled this data from. And I'll show you some more later on. But what I wanted to do was look at a couple of things. First of all, how many of them are actually using a content security policy? Now, in some cases, you don't really care. If it's just a brochure website or something like that, it doesn't really need one, probably. I mean, if you have forms on there, you probably should have something. But if all it is literally just brochureware, then you might not even really care about having one. So it's understandable that a large percentage of these don't have any CSP, but that still leaves a big chunk that have a CSP that I want to kind of dig in a little bit more on. So what I did is I took, my focus area wasn't that 81.31%. That's still a good stat. That shows you, hey, most people still don't use them, right? This technology has been around for at least a decade, and it's still not being consistently used. And then the question is, okay, well, what about that nearly 20% that are using them? How well are they actually using them? Because what I notice in pen testing is very often we would, when we first heard about the CSP, we would just call out, or we'd see from scans, people calling out that, hey, you don't have a CSP, you need to have a CSP. Okay, so this was a control that security experts were saying everybody needed to implement on their websites, but they didn't really tell you how. So it became a checkbox. And so now the question is, well, how many CSPs exist that are completely ineffective, right? And that's really what I dug in on. So to measure that, so again, focusing on that sort of nearly 20%, we'll say 18% there, I built a rating system across 6 different categories of directives inside a CSP. And I'll talk about some of those directives a little bit later to kind of give you an idea what those are. And then I broke those down into a scale that would measure these. And of course, using AI scripts, it generated scripts again, I was able to very quickly come up with okay, well, can you categorize all of this for me? And so I built out a scoring system that would tell you, how effective is the CSP that's actually there, right? So if it's all ones across the board, then it's basically just a checkbox content security policy that doesn't really actually do anything, because it doesn't have a script source defined, or it's missing most of the aspects of this. It probably has unsafe inline, and it's basically using features inside of the CSP that are just loosening it up completely. So it's not really that effective. And then I built some thresholds. So what I said is, okay, going back to here where we have these 6 different items that are being scored, if I have all of the areas were 3 or higher, I would say, okay, this is comprehensively protected, okay? And note that, oops, sorry, I just went too far, hang on. This is a scale from 1 to 5. So by saying 3, I'm actually being generous. I had to do that because when I said 5, the numbers were always 0. Like, nobody's doing that, right? Nobody is actually making perfect CSPs out there. At least from the data I had, I didn't find even one that would have rated all 5s on my scale. So I'm like, okay, well, maybe my scale's a little bit too tough. So let's just say 3 is what we're aiming for. And so I said, okay, well, let's aim for 3. So comprehensively protected is all 3 areas. All areas are 3 or higher. Substantially is 4 to 5 out of the 6 areas at a level 3 or higher. Partially, so substantially protected, that still seems kind of like we're being very loose with this, right? Just kind of letting a lot of things slide. And then partially protected is 2 to 3 areas, and then minimally is everything's below a 3, but at least one score is a 2, or exactly one component is greater than or equal to 3. And then ineffective means everything's at a 1. And so this was the output from that. So and what I found was that on a percentage basis, we have about 30% of all the CSPs that are implemented on the internet appear to be completely ineffective. Like, they're basically just a checkbox. It doesn't do anything. It's just there to make somebody happy that they implemented it. And then nearly half fall into that minimal category, right? So they're not really doing anything. And if you look at this, really comprehensive, like, so we're actually doing all of the things at just a level 3 or better on my scale, is only 0.6% that are actually implementing to that level, right? That have actually done all of the work on it. Even if you combine those two, the substantial and comprehensive, you're still looking at, it's still well below 10%, right? So it's a pretty small amount that are actually doing it. And so that kind of led me to, okay, well, maybe we need to talk about this again, because we tried like 10 years ago talking about content security policies. It got pushed out there. Some people used them. And I really think I don't think it's necessarily a required control, but it's one of those defense in depth things, right? It's an extra layer, and it doesn't cost you that much to put it there. So maybe we need to understand it a little bit better so we can make use of it. Okay, so if you don't take anything else away from my talk, you should take this part. This is where all of the, oh yeah, here's all of the extra things that it does, knowledge is, that people don't really understand. So if I take the script part out of the equation, okay, because that's the one that anyone who's dealt with a content security policy before probably understands, like the script source aspect of it. So when you take that out, what's left? Here's the extra things that it can do. So you have a frame ancestors directive that can be used to actually prevent clickjacking attacks. Okay, it can make what it does is it instructs the browser to say, hey, don't load this page into any other frames except for the frames that I've whitelisted here, that I've approved, right? So that makes it really hard for an attacker to take part of your website, like maybe your login or something, and stuff it inside of a frame that they control. So that's frame ancestors. Form actions is great, because if you think about this, if I'm able to inject HTML onto a page, but maybe you have a CSP in place so that I can't run scripts on that page, that doesn't mean I can't still deface the page in some way. And what if, or either deface it or change other parts of it. One of the main things I like to do, this actually happened on a pen test. I found, and I swear, there was a content security policy. It was preventing me from running scripts. It was in the login form that I was able to put an injection point. And it was a field, it was a hidden field above the username and password. So you kind of imagine there's 3 fields in there. I can't remember what the field was for. But it was something that was actually passed in by a URL parameter. And what I did was, I'm like, OK, that's great. I'm going to use my injection point, because I can't run scripts in here. I use my injection point to close out that form, start a new form that had its own action so that it submitted the form to me instead of submitting it to where it was originally intended to go, right? All without using any scripts on there, and it worked. Now, had they actually set the form actions on there, the CSP would have prevented me from being able to submit that form somewhere else, right? So that would have been actually an effective control for that particular form, right? And it's very easy to do. I mean, most of the time when you're writing an application, you're not expecting to be submitting forms somewhere else. Or if you do, you know where you're sending them. Like, you're going to have a list of places that are OK to send it to. So, but this is almost never, I almost never see this in a content security policy where form actions is actually defined anywhere. It's very rarely used. Frame ancestors actually is used a lot. And I'm not sure exactly why. I'm guessing that somebody gave advice, probably as a replacement for X form actions or something, or X frame actions. So I have actually seen quite a few cases of that, but form actions I don't. The base URI. So setting that one on there is important too, because the base is basically the root of everything else that happens on that web page. So if you're able to change that, then you can effectively change where that page thinks it is, like what it thinks its same origin is, right? So that's kind of an important one. Object source, that's for controlling like plugins and embeddings and stuff like that. A lot of websites don't even use that. But the feature's on by default, and CSP can turn it off. So we all know in security that if you have features in any system, you can reduce your attack surface by turning off the features that you don't even need. It becomes something that's not attackable. So why not just do that, right? So we can completely eliminate object sources from working. Image source, that one's a good one as well. There are attack vectors that leverage image tags. I don't have style source on there, but that would be another one that would kind of go in with image source. And then you have connect source, which that one's a really big deal because this is how a lot of actual payloads are going to work, right? So if they can get script running onto a page, what they're going to want to do usually is leverage that to collect information to send it somewhere else. This is how a keylogger is made using cross-site scripting, right? So if you can control the connect source, which again, this is another thing where normally when we're building an application, we know what we want to allow it to connect to, right? We're not going to let it connect to random things in most cases. There might be some exceptions, but most of the time it's going to connect to itself, or it's going to connect to certain APIs or other systems that you already own. So it's easy to come up with what that list is of things you should be able to do, but most people don't set this one. So it's another one. So that's it, right? These are the essential directives. These are the things that in my opinion, we should be doing. OK, so now we get into some of the advanced tactics, because one of the biggest problems that we run into, if anyone's on the side of telling your developers, hey, you need to implement a CSP, the pushback that you're going to get very often is, well, when I do that, it breaks stuff, right? We've all heard that one. It's breaking things. So how do we get around that problem? and how do we make this secure? And so I have a couple of things to consider here. And this is the big three advanced ways of using CSP that are out there. There are lots of other nuances that you can build in, but these are the main ones. So you have nonces, you have hashes, and then you have this concept called strict dynamic, which typically goes with nonces. And I'm going to show just a simplified example for each of these in a second. And then normally how you'll want to use these is for external scripts, those things that you're loading from outside of your application, you'll use nonces for that. For things that are already built into your application, because it's easy for you to generate a hash of those at build time or deploy time, those are things that work really well for hashes. And once you've defined those in there, and then combined with strict dynamic, you'll see, it becomes very, very difficult for an attacker to actually get a payload to actually get into that system because they won't know the nonce, so they can't guess that. And they have no way to put the hash in, and it's really, really hard to find. Like with a SHA-256, for example, it's going to be really hard for them to build a script that's going to work that's going to be the same hash as a script that's already on there. Right? There is a possibility of finding a collision, but it's really, really rare. So looking at what these actually look like. So the header, remember, so the CSP header is typically going to be a response header, right? It's going to be coming back from the server. That's not something an attacker is ever going to really have any access to. If they do, you have bigger problems. But so what will happen is inside your content security policy header, you're going to say, you're going to have script source and then nonce and some random number. And that would get generated fresh with, often what you can do with every request, right? And then down inside the script, you have your nonce actually defined where your script tags are. And because these two match, the browser will say, hey, you have a content security policy that says only run scripts with this nonce. Oh, I found a script block. I'm going to check the nonce. And it says, yep, they match. OK, I can run this one. This is safe to run. If it's missing the nonce or the nonce doesn't match, it won't actually run it. OK? And you'll get that type of error that we saw earlier. And then we have hashes are very similar, only you don't have to define those in the script, right? So what you would do is maybe at let's say, build time or deploy time, you would take the script blocks that you've already vetted and trust, and those you would basically bundle those up and create a hash, and then that would be pushed in as your header there, right? And because, like, this isn't a full hash on here, I obviously shortened it for the slide, but the SHA-256 hash you see on the top highlighted part, that's the hash of whatever's between those script tags there. OK, and then you have strict dynamic. So strict dynamic is kind of an interesting one because it actually improves some aspects of security, and it also loosens up another aspect of security. But together, it's necessary for modern applications, because what happens with a lot of modern applications is they do a lot of this sort of bundling where, well, there's bundling, and then it's also dynamically pulling in more libraries. And so it might initially load some JavaScript, and then that JavaScript has to load additional JavaScript files, and then they might load more as well. And so how do you get all of that to work without having to go through a really crazy exercise of trying to find out the hashes for all those things or try to figure out some way of getting nonces on? And so strict dynamic allows you to still use a nonce on, like, think of that like the outer script tag, but then everything inside of that will safely load. Now, the kicker is, if you're using strict dynamic, you have to universally use basically nonces throughout everything. Like, you can't have unsafe inline won't even work if it's there. It will stop functioning. So everything has to be in a nonce at that point. I think actually you can still put hashes in there too. So if you do have anything in there, it would have to be in a hash or a nonce. But this is how it allows that to work. So it does lock things down more, while at the same time it allows you to bring in other libraries, right? So now there's a couple of different options for how to implement this, and this is kind of the instructions you can go back to your dev teams on. One is if it's more of a modern thing where they're doing a lot of like CI/CD and it's maybe in a React-based application, then you'll want to use a tool like Helmet, which it's a plugin, but it allows you to actually write the security headers that come back in the response. So it can do some of that calculation of hashes for you, for example. It can also insert the nonce into the page for you. And so there's basically, it's a library set up to be able to do this for them. So that's possible. But the other thing that we have to consider as well is what about legacy applications? What if they're running something like a JavaScript app or sorry, not Java, like a Java application where it doesn't necessarily have that level of access, or it's a legacy application that you really don't want to mess with the application itself, like you don't want to mess with the code. If you're running it through a reverse proxy, this should be familiar for a lot of you who, if you do that, more of that system deployment stuff with legacy apps, Nginx or Apache or something like that, you can actually do string replacement in your request response traffic through that reverse proxy, which is kind of convenient, right? So what we can do is we can set up nonce placeholders inside the application, and then, like for all of the script tags that are there, and then have the reverse proxy actually swap those out. I would use something other than the word nonce, though, because you don't want something that the attacker can guess what the replacement word is. So maybe something you generate with each time you do a new build and have it more of a randomly generated hash or something. But I can show a little bit about what that looks like, too. OK, so to kind of demonstrate this, I had AI. See, I leverage AI a lot these days. I had AI help me build an app. And this application is just for showing some demonstrations of content security policies. So in this one here, we have no content security policy at all. So everything's going to work. And it does a few different things. I should probably see if I can zoom in a little bit. Hang on. OK. So it does. There's a bunch of different things on here. The timer, by the way, that's just to demonstrate to myself that JavaScript's actually still running on the page, because as I was troubleshooting this, I want to make sure that I wasn't breaking all the JavaScript on the page at the same time. But if I were to put, like there's this little comment form in here, and I can put a cross-site scripting payload. This one's an image source, so I'm giving it an invalid source and then saying on error alert, right? So because it's invalid, it'll error out. And then if I post that, it's going to, I get the cross-site scripting pop-up box, right? So we know the alert worked, so we're able to actually inject something on the page. And then similar to that, I have this one's for cross-origin form submission. Remember, I was talking about the form actions, that sort of thing, or the connect source type. I can't remember which one this one actually is, but let's say we just have some, let's change it to some sensitive data that's getting submitted somewhere, and let's say an attacker has managed to put a keylogger in here or something like that. So I have this other domain set up, and it's probably hard to see on here. Let me zoom in again. But we can see where it actually captured some sensitive data on here. And you may not be able to see it from where you're standing, but these are actually two different origins. So this was vulnerable.example.com. By the way, example.com is only running on my laptop. You can't go out to that domain. However, this entire demo is, it's on GitHub, so you can pull it down later if you're interested. And so this actually just demonstrates basically like a keylogger or form capture type of malware that might have been installed onto the page through scripting. So that's one. And like I said, this is with no CSP at all. So let's look at something that has a basic content security policy on here. And I'm going to do exactly the same thing as before. Hang on. Let's see. So still my name, and then the same cross-site scripting vector there, and then I'm going to post that. And we'll see that we didn't get a pop-up, but what we did get was the error in here. This is one of the first slides I showed. Remember when I said, hey, there was an error message on there saying, hey, this inline event handler violates the following content security directive, policy directive, and then it talks about how to fix it, right? So that's what that message is up there. So that's the type of behavior you're going to get. Now, I didn't install any plugins or anything like this. This is the way all browsers behave. So this is built in. All I had to do is I had this at the very top. This content security policy came back in the response. Okay, and then the browser obeyed it. It's like, okay, I understand my instructions. This is what I'm going to do. Okay, and so it did that. And because this one's actually, it's a fairly basic one, but it's very strict as well. Because this is saying default source self, script source self, style source self, form action self, so it won't submit forms to other things. Image source, it'll be any image source is okay. And object source, none, which is good. Because if we don't have any objects on the page, this is the whole turn the feature off type of thing, right? Which is what we're doing there. And then if I have my sensitive data again, this time it should just fail. See, it tried to go to that page, but the browser just wouldn't let it. It opened a tab, but it was empty. And then if I go back here, it will actually say, sending form data to malicious.example.com violates the following content security policy directive. So it actually prevented that form from being submitted, right? That's the one that nobody does this. Nobody actually sets up this directive that's right there and so easy to use. So that's another example I had on there. And then I have a couple, here's a hash-based one. So this one I took all of the scripts on the page and I put them into basically hash them up. And so I have this SHA-256 and then the hash of all my inline scripts on the page are there. So anything that's running outside is going to fail. Right, so this first button here says test inline script. Okay, so that one should fail because that one's actually outside of the hashed block on there. You kind of have to look at the details on here. Hang on. This is getting too much in the weeds. I'm just gonna pass that for now. But if you're interested in kind of digging into the details on this more later, then you can. Like I said, all of this is available. And then I have the hash script was in its own block. And so that one will actually run. Okay, so we can see we got a pop-up on that one. And it didn't put an error in the logs. And then any external script, of course, because we don't have any nonces set up or anything like that, that one's also going to have a violation. You can see the new one just popped up here. Okay. And then I do have, a bit of an example of what I did with Nginx. So I have a nonce filter on here that does a replacement and it's basically generating it off of the, I think it's the request ID or something like that. So there's a pseudo random number that's inside of Nginx on every request that's available for things like this. And so you could just use that to generate the nonce. So every page refresh, I'm going to get a different nonce. And then we have, like, any inline script is not going to be part of that nonce. Remember, the nonce is mostly for external scripts. So the inline script, of course, it's going to fail because it's not in there. The nonce-based script should work, which it did. Yeah. And so it's basically that same sort of pattern. Thanks. And then helmet will be similar to that as well. So I'm going to, at this point, I'm going to start wrapping up. And oops, I did that wrong. Hang on. Okay, I'm going to start wrapping up because I want to leave it open for questions for you guys. And I know that that lunch is coming up too, so some of you are probably hungry. So the key takeaways here. First of all, this is a feature that's in your browsers already, right? And there's a lot of capability built into the browser that is just turned on by default, right? But we don't need it all. So we can turn parts of it off, or we can limit its use through the content security policy. Like, this is the agreed upon way to do this. So we should be using it effectively to turn off features that we aren't using in applications. It helps reduce your attack surface on an application. And like I said before, sometimes you don't care. If it's a brochure website, maybe you don't really care. But if you're dealing with sensitive information at all on your application, you should definitely be having a content security policy on there and be making use of the features of that policy, or the directives in that policy, to turn stuff off in your browser that you don't need. Also, based on the data, which I ran that was just earlier this year. So this is pretty recent. Most sites still don't even have a CSP. And many of the sites that do have one it's not very effective. It's like it's barely actually being used properly. And lastly, even if your developers are saying, hey, you know, if I put a CSP on here, it's going to break everything. There are ways around that, or at least compromises you can make. That nonce replacement tactic in Nginx, that's not perfect. You're not going to have a perfect content security policy off that, but it's way better than just having a checkbox one. Like, it's going to prevent a lot of possible things from happening. If you do that, and then also do, I didn't put it on here, but going back to that essential directives page of, okay, well, putting scripting aside, what about all these other things that we can do? If you do those two things, then you can put a lot of protection even into a legacy application without impacting the application, right? So that's pretty much it. So appreciate you guys coming out here and listening to my talk. Hopefully this made an impact on some of you who are working with applications. Thank you. Anybody have questions?
What are some of the considerations in the construction of the CSP that you have to differentiate between a static and dynamic application?
Between it.
Some of the differences in the implementation processes of the CSP.
Between a static and dynamic application.
Like you had said that the hashes were used for like localized functions and stuff within the application.
Yeah.
A static page wouldn't necessarily have that, and if you have a static page that kind of hot reloads like in a React framework, how would you like implement a nonce system in such a way that like it would actually load more than just the first nonce on page load?
So you could have a single nonce for the whole page. Okay. My guess is for that situation, your best bet is to basically have a nonce generated on the initial page load, and you would use that same nonce for the entire session. So you would just propagate that through any of your trusted sources. You can do, which is something you could do dynamically at that point. Because you're going to know, your application should quote unquote know. I mean, they don't think for themselves, right? So it has to be programmed in there. But it should know which libraries are expected to be loaded, at least the top level ones. And but that's where that strict dynamic comes in, right? So, and when you're using strict dynamic, you do run the risk of supply chain. It does not prevent like if you're using a trusted library that's using something else that you haven't vetted, it's not going to prevent that from working, like from causing a problem. But that's not the type of problem that it's meant to solve. So then so that's, I don't know, did that fully answer your question?
Not fully, but it gave me a good jumping off point.
Okay. Cool. You got a question?
Yeah. Do you find any difference in the enforcement of a CSP policy across different browsers?
Across different browsers?
Yeah.
At this point, no. Yeah, they're doing pretty well with it. At least the version that I have up here, which I think is version 3, although I think almost everything I put up here is supported in version 2 of the CSP. So it does go through revisions, and sometimes some browsers are a little bit behind on them. But like if you're looking at like any Chromium-based browser, Safari, I mean, that pretty much accounts for most of what's out there, Firefox. Like that, they all support at least CSP version 2 and are working on 3 if they're not already there. So, yeah, it's a good question though.
When we're working with developers and we need to just implement stricter policies, what are some of the things we're likely to break and how can we mitigate that?
Okay, so yeah, so the question is, when you're working on a CSP with developers, what are some things that are likely to break and how do you mitigate that? There's actually another CSP header that's a report-only header that I didn't mention before. So that's a tactic you can use while you're troubleshooting your way through building a content security policy, or if you're just having a new release and you want to test it. So what the report-only does, and then there's also, I can't remember exactly how it's worded, but there's a way to actually define your reporting endpoint as well. So you can have, the report-only will still put those errors in the console that we were seeing, but it won't actually actively prevent things from happening on the page. So it won't like, so if you're trying to troubleshoot like a live application or something that's like already in production, we're trying to implement a CSP, you can put it out in report-only mode first and then monitor the logs off of that to see, did it break anything? And then as long as it didn't, then then you can move it over to the actual policy. And so you can actually run both simultaneously as well. And have a reporting endpoint for, like the report only, you actually specify a CSP there. So you can have one CSP that's report only and a different one that's in effect. So you can have 2 versions running simultaneously. And the report only you can use that to, like I said, to find the problems. So, yeah. Any other questions? Everybody's ready for lunch? All right, thank you.